So let's suppose we know one solution y1 of t, not everywhere 0. Otherwise, it wouldn't be a very interesting solution of this differential equation y double prime plus p of t y prime plus q of t y equals 0. So what does it mean for y1 to be a solution of this differential equation? Well, it means that if I took y1 and plugged it in for y, took its derivative twice and plugged in y1 double prime and y1 prime and y1, then I would get 0 for this differential equation. Okay, so we have one solution to this differential equation. What I'm interested in doing is finding a second solution. I want to let y of t equal some v of t times y1 of t. Okay, so if I do that, then y prime is going to be, okay, I'm going to have to use chain rule. So I could do v of t, y1 prime of t, plus v prime of t, y1 of t. And then I do y double prime of t. Let's see, what will I get? I'll have to do product rule twice. So I'll get v double prime, wait, hang on a second. V prime of t, y1 prime of t, plus v of t, y1 double prime of t, plus v double prime of t, y1 of t, plus v prime of t, y1 double prime of t. Okay, so I can reduce that. Let's see here. So that gives me v double prime of t, y1 of t, and then I have hang on. So do I have a v prime, y prime? Oh yeah, oh this should be just a 1 prime. Okay. No wonder I was confused. It should be just a y prime of t. Yeah, I thought I had 2 v prime, y primes. Yeah, so 2 v prime of t, y prime of t. Yeah, that's right. And then what about the v's? I have 1 v of t, y1 double prime of t. Okay, that's right. So that's what y double prime is when I simplify it down. Okay, so the point is I want to plug all of that into that differential equation. And simplify. Okay, so I'll save you I'll save you all of that. So we're going to put it all into this differential equation, and if we simplify it down, I'll end up getting, so we'll just go blah, blah, blah. Okay, I'm going to save you all that. So you get y1 v double prime plus 2y prime plus p y1. Oh, that's y1 prime. V prime plus y1 double prime, oops, y1 double prime plus p y1 prime plus q y1 times v equals 0. Now, one thing I want you to notice after we simplify this all down and get to this point is that, look here, this thing here, it looks like this differential equation we started with, except with y1 plugged in. Well, what did I say that it meant for y1 to be a solution? It means that if I plug y1 into this differential equation, we get 0. So in other words, this whole thing is equal to 0, is the coefficient of v. So really what we end up with is y1 v double prime plus 2y1 prime py1 times v prime equals 0. Now look at this. I just have a v double prime and a v prime. So I can do a little substitution. W equal v prime. And what do we get? Well, that means that w prime is equal to v double prime, so I get y1 v w prime plus 2y1 prime plus, oops, I left my plus sign up here, there we go, plus py1 w equals 0. So look at that. Now, that's not a second order differential equation anymore. It's a first order differential equation. In other words, I reduced the order from a second order differential equation to a first order differential equation. Now, how do I solve a first order differential equation? Well, go back and remember the method of integrating factors. Remember that? So I'd start by dividing everything by y1. So to solve for this, I'd let w prime plus 2y1 prime plus py1 over y1, right? W equals 0. And to solve this, I'd want to let mu, my integrating factor, be equal to e to the integral of all of that junk, right? Yeah, so you let, and then you go like that, and then you multiply through by the integrating factors. So go back and review how to solve first order differential equations using integrating factors. Anyway, when I solve this, I'll get some solution w equals blah, equals something. I don't know what it equals. So w equals some equation with a t in it somehow. All right, well, I know w is v prime, so I integrate the w to find v. And then once I find v, what was the v? The v was the thing I was multiplying by my original y1 to get my second solution. So my second solution is actually going to be, I'll take the w, I'll integrate it to find v, and then I will plug that v in here, multiply by y1, to get my second solution to my differential equation. And that is the method of reduction of order.